Welcome back, Algebra 2. We're in lesson 83. Let's discuss the product rule with variables. So we know what the product rule is when we deal with exponents. We know that when we have x squared times x3, x cubed, that ends up being x to the 5th power. And we know this is true because we can multiply x times x 2 times, and then times x times x times x, would be 3 times, and it'd be the same thing as saying x to the 5th. We know that we can speed that process up. Instead of having to write them out and count them, we can just add the exponents together. So we would just do this bit, and we just do the math on the exponent, not the variable. And that's how we get x to the 5th. We know that process. It's something we do all the time. So let's apply that to exponents that contain variables. So let's look at problem 83.1. This is our first example problem. So here we have, you can write this down as I'm writing it. We have some variables in our exponents, which is new for us. We haven't done this before, but it's not hard. It's just a little bit more complex. And complex doesn't mean hard. Complex means there's just more details to keep track of. That's all complex is. Hard means it's extremely difficult to do. This is not extremely difficult to do. You just have more moving pieces than normal. So that's what we're going to learn how to deal with. So in this problem, we have 2 x bases and 2 y bases. And a base is the word that we use that is it's either the whole number or it is the variable that has the exponent. So these variables here are our bases. So I would write the ones that go together next to one another just to keep them straight. It would make it a lot easier on you to have that clarity. So let's do y to the 2x, and then we have y 3x over 4. Looks hard. It's not. It's just complex. So what we do now, we know, like in our old problem, x squared times x to the 3, we would add those 2 exponents together to equal x to the 5th. That is all we're going to do here, right? When we have xa times xb, it just equals xa plus b. This is our product rule for exponents. Okay, that is what we do every time. This is an illustration of that. We're going to apply that to these variables right here. So all I'm going to do is I'm going to just come over and I'm going to treat these variables as if they are a math problem. These exponents, I mean, as if they're a math problem. And I'm going to say a plus a over 2. So I know how to resolve this. I know how to add these together. I have to give this one the same denominator as this one. And the way I do that is by multiplying 2 over 2 times a. And I'm just going to put it over 1 and treat it just like it's a whole number because that's what it is. So then what I end up with is 2a over 2 plus a over 2. Well, that's easy enough. That's going to be 3a over 2. Well, this becomes the exponent for the base of x. So now my answer is going to have x 3a over 2 as the exponent. That was not super hard. Not even close to being hard. It's just wrapping your head around all the moving parts and all the details. I'm going to do the same thing for y. I'm going to take the exponents and I'm going to put them in a problem of their own. I'm going to say 2x plus 3x over 4. So all I need to do is give this term the same denominator. So I'm going to multiply 4 over 4 times 2x over 1. That's going to become 8x over 4 plus 3x over 4, which equals 11x over 4. This is my new exponent for y. So I would write y 11x over 4. That is your answer. Okay, it's not super hard. It's just a little bit more complex than normal. You just have a few more moving parts, but it's moving parts that you can manage. You just have to remember this rule. When you have the same base, you add the exponents, just like this. And then you do whatever you need to do that is mathematically sound, the processes that you know, to simplify it, to add them together and bring them into a simplified form. And most of the time, that is going to look like finding a common denominator and then combining the terms. For the most part, that is what you're going to be doing. So think about, just think about taking that and turning it into a sentence and combining it. That's all we did. All right, let's do another one. This one might be a little bit more difficult, but I don't think so. Let's clear the page. This one will take a minute to write up here, so let me pause. All right, in 83.2, we have a fraction. And in order to combine these, we need to get rid of the denominator. And the easiest way to do that is to move everything to the numerator. And when we move it to the numerator, we change the sign from positive to negative or from negative to positive. So I'm going to rewrite this. I have x, a minus 2 in the numerator, and I have y, a plus 4 in the numerator. From the denominator, I'm going to pull up my x, and it's positive a over 2, so it's going to become negative a over 2. Then I have a y, and it's positive 2a here. It's going to become negative 2a here. So now I'm going to get my x's together. I have x, a minus 2, and I have x, negative a over 2. I have y, a plus 4, and I have y, negative 2a. So now that I have all my like bases together, I can do this exponent addition. So a minus 2, and if I add a negative, it becomes subtraction, so it's minus a over 2. All right, so let's deal with this one first. So this has a denominator, so I just need to give these that same denominator. So this would be 2a over 2 minus 4 over 2 minus a over 2. That equals a over 2 minus 4 over 2. And if I reduce this, it's just a negative 2. So I can take that to a negative 2. So my exponent is a over 2 minus 2. So I'm going to move this over a little bit just to give myself some more room. And let's do the y. The y exponents are a plus 4. And then I have, when I add negative 2a, it would turn into subtraction, so minus 2a. So a plus 4 minus 2a, I don't have any denominators. I can just combine. That's really easy. So I would have 4 minus a. Because this is a positive, that'd be a 1a. If I combine it with this, Saxon usually doesn't like to lead with a negative sign, so I can just put the negative back here and say 4 minus a. Otherwise, it'd be negative a plus 4, which is, if you look at it, here's why mathematicians don't like to do that. You have negative a plus 4. Remember, I told you in class, mathematicians like to write things as quickly and succinctly as possible. So the reason we don't start with a negative, if we have an option, if there's a positive term. It's because you have 1, 2, 3, 4 things to write down here, and only 1, 2, 3 things to write down here. So this is why we prefer this. It's fewer things to write, because mathematicians ultimately are kind of lazy. We like to write as little as possible. So do that. But that's the reason why. It's fewer things to write. And we try, think about scientific notation. We try to write things as quickly as possible with the fewest number of decimal places possible. So of course we would write it like that instead of putting the negative first. All right, I'm going to quit lecturing on that and go back to the actual subject, which is why to the exponent of 4 minus a is our final exponent, or our final term for y. This is the answer. That's it. Wasn't that easy? That's so easy. All right. So let's look at the power rule for variables. So the power rule is when an exponent has an exponent. So when we have a problem like this, x squared to the third power, right? Typically, now when we just have these x squared times x cubed, we add, right? We add those together to get x to the fifth, right? When we have an exponent with an exponent, we multiply. So this would be 2 times 3. And the reason for that is if we were to write it out, x squared times x squared times x squared, and this is the multiplication like we did up here, we would be adding these together. And that would equal x to the 6. 2 plus 2 plus 2 is 6. So when we have an exponent with an exponent, we multiply those together. It still equals x to the 6. It's just faster. Remember, mathematicians are lazy. We want faster. We want easier. So we do the multiplication here because we know that it's the same thing as if we added them all together and wrote it all out. So that is what we're going to do. We already know how to do that. We're just going to add variables to the exponents when we do it. So let's look at our first practice problem. All right, so this one is fairly straightforward. We have x to the a plus 2 power to the power of 2. All of that squared. Remember, we are not applying the exponent as an exponent. We're applying it as a multiplier. So we would simplify this part by just saying 2 times a plus 2. That's how we would turn that around. Okay, that's how we would solve that. And we know that would be 2a plus 4. So this would be our new exponent for x. X, 2a plus 4. That's it. That's all there is to it. It's not an exponent applied to an exponent. It's a multiplier applied to an exponent. So don't get that confused. One of the mistakes I've seen students make is doing this. A plus 2 squared. That is not what we're doing. We are multiplying it like this. So don't do that, because then you'll end up with the wrong answer. You'll end up with something extremely complicated. We don't want to get extremely complicated just yet. We want to do little bits at a time. So this is a multiplier, not an exponent when it comes to the existing exponent. All right. So if I were to write this out and show you a plus 2 squared would be the same thing as saying x a plus 2 times x a plus 2, right? So we know we would add them together. So a plus 2 plus a plus 2 equals 2a plus 4. So that's how you know it's right. You can check it this way if you need to. That is what we did here, only we multiplied and it was faster. So that's what we want to do. So let's look at 83.4. Now that you kind of have a handle on it, let's see what it looks like. All right, again, this one's a little bit more complex. Don't, boggle the mind just yet. We're going to take it one part at a time. We're not going to overthink it. So first of all, we're going to get rid of our denominator by moving it to the numerator. So let's do that first. So we're just going to rewrite everything that's already there. We're just going to pretend like everything's fine and we're not panicking at all. This does not look hard. We're just moving this one to the top. It's negative, so it's going to become a positive, and we're done. That first step was not so bad. Now we are going to do the multiplication. So I have A times B. So X, A times B, AB. That was not too bad, right? So now we have our Y. So we have Y, and this is going to be A times B plus 2. You can just write it like that for right now, just to wrap your head around what has to happen. Okay? This is exactly what's going on here. I know that I have the parenthesis around the B plus 2, and it wasn't there before. The only reason I did that is because sometimes it's easier to remind ourselves that it's multiplication when we write it in the way that we're used to seeing distribution work. Right? And we have a binomial here. We have two terms. We usually put that in the parenthesis and have the single term on the outside. So I just rewrote it so it makes sense to us. And that's very important. Write it in a way that makes sense to you. Otherwise, it's going to be confusing. You don't want that. So then this doesn't have anything else on it, so I'm just going to bring it down. Now I notice that I have two bases here. So I have X, A, B, two bases that match, I should say. And I have X, A. All right, I only have one Y term, so he's going to stay the same. This Y term is going to be Y, and I'm going to go ahead and distribute. A times B would be AB, and A times 2 would be 2A. So my Y term is finished. I can't do anything else with him because there are no denominators. It just is that way. That's the answer. But I can put these together, and there's only one way to do that. So that would be X, AB, plus A, and then my Y is already finished, AB plus 2A. That's all I can do. That is the answer. And I know that it might be, you might want to do something because these look so much alike, right? It doesn't matter. It doesn't matter. It's the same thing as if you had X to the 3 and Y to the 3. You wouldn't combine those just because they're the same number. It doesn't matter. They're separate from each other because they have different bases that are being multiplied against each other. Okay? The exponent affects the base, not the other variable. So we leave it the way it is and move on. All right, let's see. That's it. That's all we have for lesson 83. I think that it's pretty straightforward. If you have any questions at all, please feel free to reach out, and I'm happy to help. See you in lesson 84.